Tonight's screencast is going to talk about absolute value in open sentences. You guys should recall that absolute value is the distance from 0 on the number line. So absolute value represents distance. Open sentences are actually inequalities. So you'll recognize open sentences when you see the symbols greater than or equal to, less than, or less than and equal to. So we're just going to recap what we did today in class. If you have an open sentence, an absolute value open sentence, such as absolute value of x is less than or equal to 1, you can visualize this on the number line, right? We want all of the numbers whose distance is less than or equal than 1 on the number line. Right? The distance away from 0 that is less than or equal to 1. So these 2 points are 1 away from 0 on the number line. If we want all of the numbers whose distance is less than 1 away from 0 on the number line, we've got what you should recognize as the graph of a conjunction. Right? A conjunction. So when you see less than, it could also be a less than or equal to symbol, think about splitting the absolute value up into 2 inequalities and then including the word and to find the overlap. On the other hand, if you have absolute value of x is greater than or equal to 1 on a number line, you've got a number line here, and just to visualize this, you want all of the numbers whose distance is farther away or equal to 1 on the number line. These 2 dots represent the 2 points that are 1 unit away from 0, and you've got to go to the right of this in order to get farther away from 0 than 1, or to the left here, and you should recognize this graph as being the graph of a disjunction. So when you see greater than or equal to, could also be just the greater than sign. I know I was obnoxious about it in class, but again, greater disjunction, less than conjunction. That'll help you remember which is which when we go to solving absolute value in open sentences. So we are going to start by solving the problem. 5 is greater than or equal to the absolute value of 2x minus 3 plus 2. All right, so the first thing we're going to do is isolate the absolute value symbol. This is easy to forget. A lot of students forget it, but it is so incredibly important to isolate the absolute value symbol first. Here is what you want to isolate. You want to get that all by itself. So we're going to do that by subtracting 2 on both sides, and you have 3 is greater than or equal to the absolute value of 2x minus 3. Now, once you've isolated the absolute value symbol, you might think, hey, I see a greater than symbol, it is a disjunction. But remember, in math, we need to read the variable first. So when we read the variable first, it actually says the absolute value of 2x minus 3 is less than or equal to 3. So we're going to rewrite it so that the variable is first, so that we can now check out this symbol, not the original symbol, the less than or equal to sign, and recognize that this is a conjunction. So as a first step, isolate the absolute value on the left-hand side. Do not forget this. It's easy to forget. Bring everything to the left-hand side first, then decide, or just bring the absolute value to the left-hand side. Then decide if you have a conjunction or disjunction. In this case, we have a conjunction because we've got a less than or equal to symbol. You could also have a conjunction if you have a less than symbol. On the other hand, a disjunction is greater than or equal to, or a greater than sign. Once you've determined which of the 2 you have, you are going to then split it up into 2 equations. So again, over here, we've decided we have a conjunction. Our first inequality, I said equation before, This should not say equation. This should say inequalities. You're going to split it up. The first one that we write is going to be the original, just without the absolute value symbols there. Okay, so the first inequality that you write down is the original without the absolute value. You're going to write the word and in between so that you remember you're looking for an overlap. The next inequality that you are going to write down is almost the same. You start off with 2x minus 3, but you're going to flip the inequality symbol. So it was less than or equal to. You're going to make it greater than or equal to. And then you're going to negate the sign. Negating the sign means you make it opposite of what it is. So here the 3 was positive, we now make it negative. If it was negative, we'd switch it and make it positive. So that second inequality is written by swapping or switching. Switch the symbol and negate the sign, meaning the left-hand side, the number on your left-hand side is going to be opposite of what it was originally. And now we're going to, you know how to solve this, right? I could have given this to you last week or earlier in the week and you would have been able to solve this. This is a matter of simply solving a conjunction. So we're going to keep the word and in between, and we're just going to add 3 to both sides, divide by 2, and now when we come over here, I'm going to do the same. I'm going to add 3 to both sides, going to divide by 2. So we are looking for the overlapping region when x is less than or equal to 3 and greater than or equal to 2. So we're right here where we are going to find the solution set. You guys might be at a place where you don't need to have a messy graph and a cleaned up graph. X has to be greater than or equal to 0, so we're going in that direction. It also, at the same time, has to be less than or equal to 3. This is our final graph. And in set notation, we say all x values such that x is in between 0 and 3, inclusive. All right, I'm going to tell you how we test this. How do we test to see if this is correct? You are going to test a point in each interval. You've got an interval to the left of 0, so I'm going to pick a number, -1. I'm going to pick a number in the middle interval, I'm going to pick 1, and here I'm going to pick 4. And what you're going to do is you're going to test 3 times. You're going to figure out what happens when x is -1, and you're going to plug that into the original, because you might have made a mistake in the algebra or in the manipulation, so you don't want that mistake to wash out like in the end. You want to make sure that you're testing in the original. So you're going to test this, and hopefully you are getting a false statement here, because if you notice, when x is -1, that is not in your solution set. So you are hoping that that is false. You are then going to test x equals 1, and when you do that, you are hoping to find a true statement to confirm that your work is correct. And then you are going to test another point. It could be x equals 4, and when you test that, you are hoping for a false, so that you have confirmed 3 regions, 2 of which are false, 1 is true. It's not a valid proof, but it definitely should give you confidence in your answer, which is this. Okay, I want to see you test those, so show that work. All right, I'm going to give you a problem to do on your own. So you are going to do this in addition to your homework tonight. I want you to solve this inequality, 1 minus the absolute value of 3x plus 2 is less than 5. There's a couple things I need you to remember here. Don't forget to isolate this absolute value. Get that by itself. It's on the left-hand side already. If you do move it to the right-hand side for whatever reason, make sure that before you decide if it's a conjunction or a disjunction, you bring it over to the left. So I would just keep it there. The other thing you need to remember before isolating and bringing it to the left-hand side is you're going to have to take care of this negative. This is implied that there's a -1 here, and it's being multiplied by the absolute value. So don't forget that. It's 1 times the absolute value, you're going to have to divide. And don't forget what is super important when you're working with inequalities and dividing or multiplying by a negative. These things you have to do before you decide if it's a conjunction or a disjunction. Alrighty, so good luck, do the homework in the book, finish this problem, and you will talk about it on Friday.